The particle insight is a very simple to use instrument. Its fluidic system is very similar to the proven methods of laser diffraction. All the manufacturers of laser diffraction have a recirculating system. The reason all the manufacturers of laser diffraction have a recirculating system is in order to assure statistical accuracy and a statistical representation of the particles. Particles will always be missed. In the case of the ISO 13322, there may be some out of focus particles that are going to be missed. The idea behind having a recirculating system is to ensure that you actually don't miss events. So let's say you have a parenteral fluid and you actually want to run a sample, or you have a pharmaceutical ingredient, and it's imperative you do not have very large particles. Well, if you just do a single pass, you may miss all these particles. By having a recirculating system at high speed, you have a higher probability of getting all these particles. So once again, the particle insight fluidic system is designed very, very closely to what the proven laser diffraction systems of the industry do. They have an it has an organic solvent compatible pump. It does all the rinsing for you and will clean it out at the end of the run automatically. It's all automated. It's a walk-away operation. So by the time you come back, if you want, it'll have the instrument refilled with clean diluent for your next sample. So talking about flexibility, the particle insight, one of the things that is very key to it is the fact that the cell design is very flexible. Many of our customers have taken advantage of this, but basically the standard system comes with a flow cell. Although we have flow cells that range anywhere from 100 microns all the way to 5 millimeters. So depending on the customer sample needs, we can actually have customized cells. Some customers have made their own cells. Here's a sample cell from a customer that wanted to have a high pressure cell, and they also use this for inserting a tablet, a pharmaceutical tablet in it, and watching it dissolve over time. We have customers that have adapted our instrument to be online. So once again, one of the main features of the particle insight is that it's very flexible in terms to how you put the particles in front of the instrument, and basically how you introduce a sample can be modified, and many of our customers have these instruments with modified cells and online as well. So going back to what I said a little bit earlier, which is a very important point, we do follow the train of thought that laser diffraction has done it right for many years. Why reinvent the wheel? So we also recirculate the instrument, the sample, similar to laser diffraction. And once again, the fact that you actually can recirculate the sample is very important because of the statistical accuracy. It's just very critical. Okay, so now one of the other benefits of having a recirculating system, and one that gives random orientation, is that there is no such thing as a particle that only has 2 dimensions. Everything has 3 dimensions to it. So if you have an instrument that only looks at 2 dimensions, like a microscope, you are kind of cheating yourself in some cases. In some cases, depends on the sample. In this case, this is the example that I mentioned a bit earlier, where we have a sample that the customer wanted to know if the thickness of the particles of the crystal flakes are different as they get larger. And if you only had an instrument that looked at 2 dimensions, you wouldn't be able to see this. Because the particle insight is a recirculating system, number one, and it does try to orient particles randomly, we have the ability of seeing quite a bit of information. We can actually go in and, looking at bounding rectangle width, we can actually identify that there is some kind of a peak here in the large size, and if we look at those thumbnails and we look at a sample of those thumbnails, we can see that these particles are the ones with the largest face to the camera. At the same time, if you look at the smaller part of the distribution, we can see that the particles below 30 microns are the particles that their thinnest portion is facing the camera. And once again, here we've proven that some of the particles are thicker than others. So it holds true that these are not uniform in thickness. Obviously, the histogram in between are the particles that are not with their sides to the camera, or not with the face to the camera, but kind of in between as they're rotating through. So once again, random orientation is very important. So we just touched on something real quick where you can actually go in and look at selective parts of distributions. Let's look at that a little bit more in detail. So this is actually very interesting, and many of our customers do like this. many times there are particles or samples that have multiple populations within the sample. You may have some stick-like particles, you may have some round particles. Because you can actually look at the thumbnails, we can actually determine how to differentiate by different shape measures, by a combination of different shape measures, how many stick-like particles there are and how many round particles there are. This has been a very useful tool, especially with shape analysis for customers. We can actually determine, in this case, we have the sample where we wanted to find out long, thinner particles compared to bulky particles, and we determined that looking at aspect ratio, at an aspect ratio greater than 2.1, we found 11.31% of the entire population, which was 2,256 particles, were stick-like, and a very large population, 88.69%, were round. Now, depending on the sample, in this case, if this was let's say a chromatography packing material, if you had a very large population of stick-like particles, the particles would not pack in very well. So determining what percentage of each population you have in your sample is something that's been very interesting to customers. Customers that do this on a regular basis also use what's called the particle classification feature. The particle classification feature is something that with one touch of a button you can go in and you can actually look at different populations by hitting these three buttons. So in this case, if we look at this sample, which actually was from some wear debris that was in oil, we can determine that there were some water droplets. Now, by going ahead and determining what the parameters are for a water droplet, we can go in and then press the statistics button, and then we can give you the 30 different shape measures, if you select to choose them all, the 30 different shape measures just for the water droplets, ignoring everything else within the sample. So you can actually get a sub-analysis of all your particles within one analysis. We can also show you the thumbnails of just the water droplets in this case. And we could do also not only the thumbnails and the statistics, but we can also give you a particle listing. And the particle listing shows you every particle that was found. So that's particle classification. Going back over to what we call the correlation plots, and we mentioned this a little bit earlier, where we could look at the thickness of particles as they change, as their size changes. The correlation plot also offers something very unique. It offers the ability to look at the comparison of any two shape measures, and then look for any kind of odd particles that are sticking out. You can look at a sample population here. We could look at a sample population here. In this case, each dot represents a particle. Not only can we see this oddball population, but we can actually go in and we can actually show you exactly what those particles are. Were they agglomerates? Were they not agglomerates? And you can actually look at the thumbnails. So once again, another nice feature where you can actually report information in a way that other traditional methods you could not see. And the fact that you can actually justify what those particles are, qualify them by images, is very unique. Another unique feature that we have for displaying information is the iPad app. We are the only company at the moment that has an iPad application on the market. The iPad basically app, the way it works is the particle insight at the end of the analysis, if you choose to do so, can upload the data into a cloud. The nice thing about this information is wherever you are in the world, if you're logged in with your specific password for your particle insight, you can actually view all the samples that have been done that day, let's say. It does not download a report. It downloads data. The data that you download basically will give you all the different shape measures that were analyzed. This is a very dynamic tool. And it will also allow you to just look at specific portions of the population. So for example, let's say in this case, you wanted to find out how many particles you had greater than 40 microns. You can actually put your finger and drag it over, and it'll in real time calculate how many particles were greater than 30 microns and what all the statistics were. So a very interactive tool for the iPad. Still going along the lines of reports, we have a broad array of reports. We'll touch on a few of them, the most common ones. We have what's called the large and small data windows. The large and small data windows are basically the way that we show data. We can actually look at portions of distributions and look at the count with all the different statistics. We also have the ability, which I think is very important, of comparing comparing results. So let's say you had a lot a year ago or a month ago versus this month. You can actually overlay the results. Now, people that are used to using particle size analyzers are accustomed to this, but that's only by size. The fact that we are using a shape analyzer allows us to not only look at size, but also look at different shape measures. Ferret width, ferret aspect ratio. We could overlay shape as well. So was the shape different? Maybe the size is not different from one lot to another, but let's say the shape or the opacity changed. We can actually show you those differences, not by size, but look at it by other shape measures as well. Another feature that we have for reporting information is the ISO 446 reporting for oil contamination. This actually meets the requirements for the wear debris market, for the classification of different wear debris, and we give you all the results. In addition to this, we also use the particle classification for this type of reporting. And lastly, one of the reports that we obviously give a lot of flexibility to is Excel downloads. We give the ability to download Excel reports automatically at the end of a run. These are created where each tab is represents all the different statistical information for the sample that was run. We look at ferret fiber aspect ratio, width, length. So every sheet has its own statistics. We also have the ability of giving you a particle listing, where every particle is listed. Let's say you ran 50,000 particles. It'll be an Excel file or a text file that's 50,000 lines long. It'll tell you exactly what frame every particle was found and the shape analysis results for every single particle as comma delimited or in every column. So very robust reporting features, and the software is also very unique. So I'm going to give you a quick demonstration of how the software works, and we'll do that right now. Here we have the Particle Insight software. Very easy to use. I'm not currently connected to an instrument right now, but if you had to run a new sample, you would just press the new button. You would type in your name. You would hit OK, and then you would just hit Clear Start. Very simple to use. When the actual sample is done, I'll show you just a few quick features of the Particle Insight software. You generally will look at histograms. This is what you normally would look at first. We have a total right now of this sample, only 18 measures were run. And in this sample, you can see that there are two populations by size. We have some particles that are somewhere in the 40 micron range and something in about the 60 to 70 micron range. So two different populations, which is interesting. We look at smoothness. We can look at circularity, all the histogram results that you like to look at. Let's close that. It's nice if you have two monitors, but then what we can actually do is actually say, okay, well, let's just look at one of the populations. Let's say you're interested in seeing only the population of particles that are, let's say, between 60 and 100 microns. You can actually say, okay, well, I want to see these 1,616 particles between 54 and 116. We can actually go in, and this is the beauty of it, we can actually go in and say, okay, only show me the particles that were from, I think I said 54 to, let's keep it at 500. And we can actually just go ahead and hit show me the thumbnails. And we can see, once again, selectively just the thumbnails of interest, or we can look at every single thumbnail. We can see here that obviously this is a latex and some debris, but we can see what these particles are. We can actually close that and have it show me every particle. We can actually eliminate the limits, and I can scroll through all, in this case, 15,000 particles that were run. We can do that as well. So once again, you could selectively look at certain particles. You can actually look at every single particle. And the beauty of it is you can actually determine what percentage of what was in your sample. What percentage of one particle versus another one was in your sample. Another thing I'll go over quickly, and then I'll stop because we have other videos on these different things, are the multiple run summaries. The multiple run summaries, once again, are where you would actually look at data comparing with, let's say, a previous lot to an existing lot. Once again, sometimes size doesn't say everything. Size isn't enough. We have obviously different types of pollen here. In this case, we could look at different statistics. We could look at do Excel worksheets out of this. But we can actually see what some of the results look like. But once again, it's not only size that you want to look at. You want to look at different shape parameters. Circularity, for example, I know in pollen, one of the things that's very important is some of the broken pieces of pollen and how many there are. Well, you can actually look at that and look at it by aspect ratio and say, well, there are certain pollen that may be uniform, some that have circularity or smoothness. I think circularity is one of the different differentiators where you can actually see some particles are less round, and these may be a population of the broken or less uniform round particles. So that's it right now for the Particle Insight software. I just briefly wanted to go over some of the information. I'd like to thank you for your time and have a wonderful day.